Yeah.
Okay, just give me a few seconds. And we are live right now.
Okay. Hello, everyone, and welcome to our March meetup. And actually, we are supposed to do this meetup last month, but we push it as it was Koshek's idea to do it on the Women's Day. And today we have a very special day, actually. This is the first meetup since like 2014 or 2015, where we're having two women as speaker. And I was talking with Wendy just now. Hopefully we keep in touch so she can bring us all the talents, and they got more involved in our community as well. So this is the design of Gohar, and Koshek, our as well organizer, he just added this cool design, break the bias, which we should do that. So today we have Wendy and we have Sarbani. So Wendy will be talking about rise of conversational AI, which very interesting topic. We've been working on Astro on something very similar. I'm looking forward for this talk. And we have Sarbani, which will talk about how to build an end-to-end machine learning pipeline, which is an interesting topic as well. So before we get started, we have some call outs. If we are following us on YouTube or following us from meetups, if you don't have any question, you can just mute your mic. If you do, we prefer to unmute yourself and ask directly the speaker. But if you don't have a mic for some reason, you can just leave your comment and our speakers will answer your questions. If we finish a bit early today, maybe we will have a network session. So usually we have these sessions where we just talk about cloud in general, about if you are changing your jobs, looking for any jobs, you can just talk with the community. Okay, so we will be starting with Wendy as our first speaker. So I will pass it to you from here, Wendy.
Hi, everyone.
Whenever you are ready.
Yep, thanks for having me. I'm just going to share my screen. So share the entire screen, isn't it? So your entire screen. Yep. Okay. Oops. Share. Okay, let me know if you can see my slides. Am I sharing my screen?
Yeah, it's very clear.
Great. So welcome everyone. My talk is going to be about just customer experience using Amazon Lex and just the rise of conversational AI. And I'm just going to walk you through slowly, why we've got the rise of conversational AI and the different use cases. This is what we're going to go through tonight. So just a quick intro, what conversational AI is, what is Amazon Lex, some use cases in government, high-level architecture using AWS ecosystem, a quick demo using an example bot, and also a custom bot, and where you could find sources of transcripts as well. Just a little bit about me. I'm a finance person who changed careers to data science. I've worked in consulting for PwC, and also I've consulted for an AI startup for things such as license plate recognition, data mining, and also government. Presently, because of COVID, I'm a business analyst at the moment in government, and we're working across the contact center. I'm also heavily involved in Women in Data Science at Stanford, and I was previously an editor of Towards Data Science. Just a little bit about where I work at the moment. So I work for Service New South Wales, which is part of the Department of Customer Service. We're very customer centric, and we want to engage with the citizens of Sydney through multi-platform channels such as SMS, mobile apps, the website, and really improve the customer experience. We're like the Google of government. So we use AWS at the moment, and we try to understand our customers as our agents take calls, but also, exceed and understand, and, just to prompt. And we also, people come to us as a one-stop shop to pay bills, to also find relief for flood payments as well. And we also have a mobile app, and anything to do with community, it's our government, which is Service New South Wales. So I just want to touch briefly what is conversational AI. So Deloitte Consulting actually specialize in conversational AI. They have branches in China and offices in the US as well. It's just basically an intelligent way of offering conversation, like using digital and technology to mimic human behavior using natural language processing. And then just 8 components of conversational AI includes natural language processing, understanding the key, which is the intent. So in the contact center for government, we want to understand, why does the customer call us? What do they want? What's their user request? And then conversational AI will also include entity recognition, fulfillment. So how are we going to fulfill the customer's need or fulfill their request? So we're going to use APIs, we're going to use databases, pulling data from the web. And we're also going to understand the customer through text to speech. So we're going to convert text to natural language. So we're going to, we also look at sentiment analysis as well. And then also machine learning is involved. So in particular, with the future of contact centers with agents, they're going to be able to predict, what the customer's intention is, and also have tools to help them search online as well, such as using Amazon Kendra to help them prompt and provide a better customer experience. So the right questions that they can search online while they're on the phone with the customer as well, and also understanding context. So at the moment in Sydney, we've got New South Wales floods, and every day we're doing sentiment analysis to understand what's the topic modeling, what are the keywords search for why people are calling us in government. So just want to touch what we're going to discuss this evening. So it's Amazon Lex, and this is not something that we use in my at work, but this is a type of conversational interface that Amazon have developed. It's an AI, it's a machine learning service that builds conversational interfaces so that you can communicate with the customer via voice or text and understand them with human behavior as well. So Amazon Lex version 1 has been around for quite some time, but the exciting thing is with reInvent 2021, around about December last year, there was a new launch of Amazon Lex V2, which is the Amazon Lex automated chatbot designer in preview. So it's still currently in preview. When you sign into the console, when we go through it later on, you have the choice of choosing V1, or you can just quickly revert to V2. The beauty of V2 is that instead of taking developers many weeks to develop a chatbot, you can actually build a prototype in a test environment within minutes. And it's really easy to use. Interface is quite simple as well. And you can analyze thousands of lines of audio transcripts. So the key driver of a contact center or building a mobile app is understanding what does the customer want, why they're calling us, why they're chatting to us on the mobile app in the evening as well, like booking a flight, booking a hotel, etc. And oops, just gonna move on to the next screen. Just want to touch briefly on 3 key terminology that you might want to understand before we dive deep into Amazon Lex V2. So as mentioned, the intent is why is the customer calling us? What does the user want? What user requests do they want us to perform as an organization? And then utterance is another terminology that you'll come across as well. So utterance is the different way that the customer can ask the question. So it could be they want to pay the bill, or I would like to make a payment. And the quite interesting thing is if you use Google Analytics at work or for personal projects, you can sometimes understand different ways that people search for key terms. So if they want to make a payment of a bill, they're like various utterances that we can develop as a development team to sort of provide a better user experience for the customer. And then fulfill intent is how we're going to fulfill the customer's request once they provide more information to us. And then we also have different slot values as well. So different types of pickup times that we can build in as well. Oh, sorry, just jump into that. And just want to touch briefly on some use cases. So the reason why we build a chatbot is if you work in a contact center, which is quite busy, you want to reduce the volume of calls. You want to encourage your customers to revert to digital and self-service. So particularly if they're completing forms, instead of calling the contact center multiple times during the day, how can we provide like a concierge service to like route the different calls to the different areas using IVR. And then we also analyze different use cases. Is it going to be a simple transaction or will it be a complex transaction? So something simple is when you map out with the business requirements as well with the contact center managers, a simple transaction could be I pay a bill every month and I want to automate that with a chatbot. So what sort of conversation and utterances can we develop and map out for the conversational design to deflect calls? So our ultimate goal is to deflect calls. And if something is complex, if something is deemed complex, we will revert that call to a contact center agent. And other use cases is that you could deploy a chatbot on a website, particularly if you're doing shopping online or you want to book a hotel in the evening where it's non-business hours. And we're just going to walk through some of the things that you might consider when you're designing conversational AI interfaces with your team. So the number one priority is identify the use case and what does the customer need. And the way that you do that is you could analyze multiple transcripts from the contact center. And in this example is in Sydney, just fill in a few sentences and a range of conversations. So if you're a citizen in Sydney, what is it that you want to achieve? So I would like to make a payment. I would like to pay a fine, a parking fine. So the end user would be the citizen, and then you just need to work out what task will be completed. And some of the tasks could be, I would like to renew my car license. I would like to pay for license plates. And then the way that the chatbot would work is if it's a simple transaction. If it's something complex like COVID-19 that changes constantly with all the different government regulations, it wouldn't be ideal for a chatbot, but something that's ongoing. And then we also have a use case too. So for example, just say you're dealing with government, you're a citizen, and you'd like to make a booking, you'd like to make an appointment of some sort. So the task that you would like to achieve is, I would like to make an appointment for a COVID vaccination. So in the government agency that I work for, last year we were responsible for the COVID vaccination hub across the state. And we're also responsible for booking driver testing, like learner drivers, or otherwise booking an appointment for stimulus grants to get the economy to run again as well. So small businesses that were out of work, they receive like government grants as well. So they could book an appointment to see the government. So these are types of simple transaction and they're not complex. So the chatbot could develop these potentially. Just like to discuss the high-level architecture as well of Amazon Lex. So for example, you'd have a contact center in a call center, and after the conversation, it's recorded, there's call recording. And with that transcript, it's stored in a cloud. It's not necessarily Amazon, it could be like another hybrid cloud or another multi-cloud as well. And then this transcript, you can then ingest it into Amazon Lex Automated Chatbot Designer, which is Amazon Lex V2. And within the cloud environment, there will be natural language understanding and there'll be deep learning. And with deep learning, because it analyzes patterns and it just recognizes lines of transcripts of conversations from the customer, it will remove all the ambiguity and anything which is overlapping as well. And it will output the intent, what the customer wants, why they're calling us. It will also output the associated phrases and also the values of different slot types. Does anyone have any questions at this stage? And we're just going to walk through a demo now. Yep. So any questions from anyone whilst we pause here for a bit? If not, I'll just move on to the demo. So we're going to create a bot with existing data. I'm just going to stop sharing and just move to another screen. Just bear with me. So we're just going to go into the Amazon Lex console. So you'd sign into the console and then you'd type, oh, am I sharing screen? I just want to make sure that I'm still sharing.
Yes, you are, Wendy.
Okay.
We still see your screen, yeah.
Thank you. Okay, so once you sign into the Amazon Management Console, in the search bar, just type Lex, and that will take you straight into the service. And as you can see, this is Amazon Lex, and this is V2. You can go back to V1 if you're comfortable with that, but we want to test drive today V2, which is more efficient, might be quicker for you as well. And so we'll go into V2 over here, into the V2 console. And then all you do to create this bot is, in our example, we're going to book a flight. So if you go create bot, and then let's just start with an example firstly. So click on this option. Let's start with an example with existing data. So click on the drop-down menu. We'd like to book a trip. And then just give your bot a name. So for this example, I'll just write demo book bot. And then you can provide an optional name. So it's the help desk of the travel agency. Just to understand what the purpose is for this bot. For Iem Permissions, you'd like to create a new role. So that would be create a role with basic Amazon Lex permissions. And then the Iem role will be created down here. And then also, due to privacy reasons, you just want to make sure that there are no, that the bot that you're creating, there's no sensitive information for people that are, underage as well. So tick no in this instance. And that's all you need to do. Leave the default settings and then click on next. And then we'll just take a few seconds. And then with Amazon Lex V2, it defaults to US language, US English. You can provide a description if you like. And there's various different voices that you can test drive. For example, you can listen to Kendra.
Hello, my name is Kendra. Let me know how I can assist you.
And if you wanted something which is more standard text-to-speech, you could pick an option under standard text-to-speech, such as Joanna.
Hello, my name is Joanna. Let me know how I can assist you.
So it's really up to your personal preference. So we'll stick with, so in this instance, I'd like to choose Kimberly. And
hello, my name is Kimberly. Let me know how I can assist you.
And you can add multiple languages as well, not just English. So you can have a look at the Amazon documentation if you wish to add multiple languages for your chatbot. So we'll just click done and we'll just wait a few seconds. And then with the intent, Amazon Lex V2, it will produce a sample of intents as well for you. You can have a look and you can inspect them. And then also from here, you can just click on build. I want to build my bot. And it will just take a few seconds. Okay, so it's quite quick and it's almost done.
While that comes up, Wendy, I have a question for you. This is Kaushik here.
Yeah.
So from a scalability perspective, how does Lex support scalability for number of interactions that come through?
Oh, so yeah, it can read like thousands of transcripts. Yeah. So we can get to that when we talk about the custom bot.
Okay.
This is in preview. So because this was launched at Amazon, the reInvent in December, it's still in preview. It's available in US, and it's to expedite your to find out what the intent is for building your bot, so it can analyze thousands of lines of transcripts. But this is recommended for test environment for dev and not for production. So I think they're still working out. There was a blog about that as well. It's just V2, you can use it, but it's recommended for test. And so here, because we built a bot here, we're going to test this bot. as well. And it's going to open up into a different editor. So now we can interact with the bot and you'll just ask a question. So I can just type, I would like to book a hotel. And then it will mimic human conversation and what city you like to stay in. So I'll say London. And then it's just having a conversation. It's learning from the text as well, natural language understanding. So I'll put in Monday. I'd like to check in on Monday. And how many nights are you staying? So 7 nights. So it's as easy as that. And then if you have a look at the plain text, if you inspect the intent as well, this will open up into JSON output. So you can have a look at the code and the summary. And so this is an example of creating an example bot with existing data. Does anyone have any questions with this example for the moment?
So if I want to connect it to the backends, I can use Cloud Lambda functions,
Yes.
and I can connect it directly to my backend.
Yes, you can. Yep. It's in the
Right.
documentation. You can link it to Lambda.
Right. I have another question. Do they have now with Lex, if I want to connect it to my call center like a phone gateway, do they have an option like this? Or
yes, there is. Yeah. In the custom bot, which I'll show you later, there's an option for transcripts. You can connect to Amazon Connect. So it's definitely there's a functionality to build for a contact center.
Great.
Yeah. And then also, it's also, you can link it to like messengers like Slack, or you can link it to Facebook Messenger as well for these bots. Yeah.
What about WhatsApp?
I didn't read any, probably have a look at the documentation, but they mentioned, Slack and Facebook Messenger. Yeah.
Oh, that's great.
That's a good question. And yeah, so this is really, you can see how quick it is to create a bot in a few seconds just with example data. And you can interact and just ask questions and look at the utterances that it just produces. It's just interacting with you and providing a good customer experience. Does anyone have any questions before we move on? Okay, if not, we'll move on to the custom bot. So in the example, just wanted to go back to the slides as well. So here we've just gone through, we've built a sample bot, booking a hotel. And then next, we're just going to discuss, am I still sharing my screen? I think I am. Just some of the challenges for looking for transcripts is quite challenging because it's a little bit difficult to find conversations for a contact center due to privacy reasons, consumer law as well. But be creative, have a look at some data sources for audio transcripts on Google Data Search, even on Amazon, the data exchange as well. Also Kaggle.com and also GitHub. So in the second demo that I'm going to show you right now, I just did a Google search on Google just to find, on Kaggle, what sort of audio transcripts I could find. And I found this transcript in JSON, which is Star Trek. So I found it quite interesting. So we're just going to inspect that. And so, be creative, what interests you, and see if there is an audio transcript that exists. And just a recommendation for Amazon Lex V2, when you load this transcript into S3, it has to be in JSON format. And let's move across and I'll just show you now. So if you go back to Lex and we want to create a second bot. And this second bot, in this instance, just want to show you, so for example, I'll just show you, just if you were going to Kaggle.com and you were happy with this transcript and then you just wanted to download it, you can download it into your personal directory and then, save it into your folder. And I've just completed that earlier, which is saved here. So that's the Star Trek dialogue V2. And I just wanted to also show you the S3 bucket that I've created. So make sure that you've created an S3 bucket. So just some prerequisites that you need to complete as well. So you create a bucket, which in this instance I've named test star. I've created a folder as well, and then I've uploaded the Star Trek dialogue. So that's here in JSON format. And then let's go back to Lex to create a custom bot. So go back to, you want to point it to V2 console. Okay, and then just click on create bot again. But in this instance, you want to select the option, I want to start with transcripts. And so give it a name. So in this instance, I'll write demo, custom bot, demo, Star Trek bot. Okay, and then just write like a description that will help you, like the purpose of the bot, help you find your way to the moon. Okay, and then also you'll need to create a new role for IAM to include all the policies as well attached to Lex V2. And then also click on no, this bot is not going to be created and no miners are going to use this chatbot. Keep the default settings and just click on next. And then as mentioned before, it will default with this preview with automated chatbot designer in preview, it defaults to US English. And then you can select the preferred chatbot voice that you'd like to select. So you can select, have a look at Joey.
My name is Joey. Let me know how I can assist you.
Okay, so we'll stick with Joey for this instance. And then you'll select the S3 bucket that you've created earlier. Oh, actually, one would have thought just need to, with that, I'm just going to go back to S3 because the S3 bucket is not picking, I'm in Sydney region. So let's try S3. I change it to US Virginia. I'm just going to change regions. So I'm just going to go back to my S3 bucket, make sure. Because you're searching for the JSON file that you've saved. That's global. Okay, let's go back to Lex V2. Okay, so I just want to make sure that I'm interacting and creating a bot in Virginia or like a US region. Okay, so let's go create bot again. Start with transcripts. Okay, so demo Star Trek bot. Okay, help us find the way to the moon. Yep. Okay, and then also in Iem Permissions, click on create a new role. We're not going to expose the bot to any minors. Okay, click on next. Okay, US language. So we'll select Joey again.
Hello, my name is Joey. Let me know how I can assist you.
And then we want to search for the bucket, the S3 bucket that contains the JSON file. Okay, and then just going to leave this blank. It's optional. Okay, you can leave this as default setting, and for the transcripts, you can specify like a date range with a Star Trek dialogue. I'm not too sure because it's not like a contact center transcript. I don't really have date parameters, but I think I'll just input this for a demo purpose as well. Oops, maybe like the month of January. Okay, and then you can add an additional language if you wish, as opposed to US English, and then just click on done. And then just going to wait a few seconds as well. So this bot should build, and I had some issues just with troubleshooting this as well. The transcript seemed to fail, so I'm still working through with this just to work it through. And I'm just also looking at S3 replication of the bucket. So yeah, I wasn't able to produce a custom bot, but I'm still working through that. So yeah, but then if this was working, it would produce like all the intents. The bot will be created, and then you can analyze the different utterances as well, and then you can interact with it. So that's it. That's pretty much the end of my presentation. I'm open for any questions that you may have. Yeah.
I have a couple of them, Wendy. So from a security perspective, specifically with the bots, what are the key things that anyone who's starting off should be looking at to secure the bots, right? In general, be it just spams or anything, how do you manage that?
Oh yes, the S3, you can encrypt it. So there's an option, you can tick on S3, encrypt the data. You can also put Maiti, so particularly if you're working in government, you can just run through the bucket, make sure that there's data that can be redacted as well, like for PII. Yep. And then also with the new, there's a new API which is called Amazon Transcribe Call Analytics, specifically for contact centers. That will redact conversations as well and just bring an alert. So that's a good question. Yeah.
Okay. And were you able to actually, have you implemented this in real life for any of your companies that you're working with?
Yeah, no, it's just more of a personal project. In government, we're not actually using Amazon. So they're using another cloud provider, which I can't name.
Sure. Yeah.
And they're actually using multi-cloud, but not Amazon, unfortunately.
Sure. Yeah. No, because I was keen to understand, because you mentioned about integrating with Connect specifically. Yes. So were there, I wanted to understand, did you also evaluate connecting with other contact center solutions like Avaya or others? So wanted to look at that.
I did actually raise my boss. I said, wouldn't it be great if we, connect it to Amazon Connect as well? Because we can also link it to Salesforce. Because you know how Amazon has a contract with Connect and Salesforce as well. They can link Kendra and then predict, what the agent is saying and provide an even better customer experience and give them search words and key phrases as well. But we've got a contract with another cloud provider, which I can't name, so we can't implement that. Yeah. Oh, sorry, on mute. Yeah.
Sorry. Anyone else question for Wendy?
Oh, Sarbani.
Yeah, hi. So regarding the pricing, I mean, how is it cost effective in compared to any in-house inbuilt bot?
Oh, I haven't analyzed the cost. Yeah. It specifies the cost in the documentation, so you can definitely have a look. It's just quicker. You can also have a look at the blog as well that was released after reInvent on December 1st for Chatbot Designer. It's just really, as I mentioned before, it's for test environments. It's really recommended for dev, not for production. Yeah. Okay. But maybe they're going to provide another iteration. So this is V2 and they're going to release other features later on as well. But this is quite exciting because you can see how quick it is.
Right. That's all about the cloud.
Yeah. Brilliant. And another note, it's hard to find transcripts. So it's hard to mimic a contact center. So I found that as a challenge, like what could I use to mimic a contact center and in JSON?
I worked on it a little bit on Rasa framework, Rasa. I found it a bit complex and kind of quite resource consuming on the local environment. It was kind of getting hanged. And there are a lot of pieces we had to build. I mean, that was again a kind of, testing. But yeah, I think that looks quite good, neat and clean setup.
Yeah, and I think, as you saw with a custom bot, I wasn't able to produce it. So I'm going to go back and look at perhaps S3 replication, batch replication, because, as you know, I'm based in Sydney. It could be because it's US. So I'm just going to test a few things, and I just couldn't implement like a custom bot with that JSON file. But you could also have a look at that Star Trek file, and perhaps you can try it out yourself as well. Yeah.
Sure. And for all those who want access to the files, Wendy has shared her deck. We'll probably share it across over the user group, and you can have access to all those GitHub resources that she has shared. So, right. If no further questions, my colleague and friend Mo had to step out, so I'll take over the emceeing from here on. So I'll be your host. So thanks a lot, Wendy. Thanks a lot for actually with your time, and I believe it's almost dinner on nighttime for you.
Oh, so 11, it's okay.
It's 11. Right. So thanks a lot. Thank you for taking out your time for us. So yeah, and we would like to quickly move on. So I would like to share my screen. Okay. I have some concerns with sharing my screen, apparently. All right. So we will move on. So basically, we do have hiring updates. So whenever we have any one of you looking to hire locally, reach out to us, or you can fill in your details in this link that I've shared in the chat. For those who are here, feel free to put in your open positions, and we'll shout it out in our next session, right? And also, if anyone is seeking for a job, share in your details as well, and then we can probably mix and match. And we are trying to use this community to let people connect in this thing. Yeah. And if you're looking to speak like Sarbani and Wendy, please fill in your details over here. And if you're interested in this link, and we will reach out to you for the next session that we would have, right? All right. So with that, we would like to move on to our next speaker, Sarbani Maiti. Thank you again for taking out the time. And her topic is, she is an AVP and cloud service and AIML in Magic FinServe. And today she's going to be talking about how to build an end-to-end machine learning pipeline in using AWS SageMaker. So, it's a heavy packed AIML session today, and it's a Women's Day special session that we have tried to put together as well. So again, the floor is yours, Sarbani. Over to you. You're on mute, so if I may ask you to unmute.
Yeah.
And
Thank you, Kaushik. Thanks for the introduction. Okay, I have to share my screen.
Yes, please.
Okay, just give me a minute. Okay, I'm putting it on the slide mode.
Sure.
Okay, as Kaushik said, my name is Sarbani. I'm working as AVP in AIML and Cloud Service for Magic FinServe. Today's sessions, I'm going to discuss what is machine learning pipeline and how can we build an end-to-end pipeline using one test dataset in Amazon SageMaker. To start with, we all know these are the very high-level machine learning lifecycle stages, starting from data collection, data cleaning, feature engineering, model training, evaluation, optimization of model selection, and deployment. This is one cycle at the high level, but in reality, in production, it's not a simple cycle which can be deployed and we can quickly get the result. There are several challenges in production. One is that seamless integration with existing IT and the business applications which are already running in the house. Second is that successful adoption of the consumer services. So in both the areas, we have seen a lot of challenges with the existing system, how to integrate the machine learning output, which is nothing but your recommendation or prediction, and we can seamlessly integrate with the existing system. Now, when we're talking about prediction, it can be both the type. One is the real-time prediction or the batch prediction. In real-time prediction, challenges are more because a lot of time we need to talk about scalability, security, and availability of the prediction output, which can be used by our real production system. Other components are ROI target, complicated infrastructure, high maintenance, because infrastructure, high maintenance are always kind of impacting our day-to-day cost. So with all these challenges in picture, if we can look at one very high level end-to-end machine learning system, it may look like so complicated. So here in this particular diagram, yeah, I have clubbed a lot of modules together just to give an idea how different groups are working together in one data science project. So we have a different groups like data engineers, data scientists, ML engineer, and data analyst. Data engineers are taking care of all the data pre-processing, data cleaning, data ingestion, and finally creating the training data for the model to train. Data scientists are taking care of all the model development, model optimizations, using several different frameworks, choosing the right algorithm, tuning it with various kind of optimization technique, and create the best fit model for rest of the pipeline. ML engineers are kind of having a overall role across the platform where ML engineers can take care of the infrastructure, different tools, and different integration orchestrations end to end. Data analysts are working on various data analytic tool, and they are mostly taking care of visualizations of the analysis so that business people can understand the result quickly and easily. In this entire workspace, we are primarily talking about three different pipelines. One is that data pipeline, model pipeline, and then third one is the model serving pipeline. In the data pipeline, we'll talk about data loading, data preparation, data cleaning, creating training, testing data set, and finally feeding the data to the training and model pipeline. Model training pipeline will have the different framework, running the algorithm, model, mostly the hyperparameter tuning. This kind of jobs are quite important at this phase, and finally building a final model. And model serving techniques is kind of serving the model for the production. Consumer applications will get the prediction and recommendations through API or gateway or by batch transform process, and there are various way we can expose the output or endpoint to the rest of the world. The entire orchestrations and entire workspace is coming under ML Ops. ML Ops is nothing but DevOps, which is created for machine learning system. In the ML Ops pipeline, we take care of a couple of areas. If I just go to the second slide, next slide. So ML Ops, the high level objective of building such a pipeline is availability, scalability, and security in production. Once we build the model, it must be available. The right kind of tools and technologies must be integrated easily so that it follows the change management policy of the organization. Maintenance, reusability of the tools, tracking, monitoring, alerting are other important aspect of the availability of the system. When the model is running in production, scalability is another important topic. Depending on the workload, our system must be auto-scaled with more number of instances, which is horizontal scaling, or we can talk about the vertical scaling where we can upgrade the infrastructure to the higher version to manage the load. And when load goes down, we should be able to decrease the infrastructure requirements and the number of instances so that we can optimize the cost. Security is utmost important in current era, and all the data what we are using in our system must be protected. Data at rest and data at motion are managed through various kind of security, managed security system, and data must be encrypted. Audit and trace activity in productions environment are also important. Various regulatory and compliance controls are need to be established in the machine learning system depending on the industry. So like healthcare, they have their own regulatory requirement. Financial industry, they have their own regulatory requirements. With all this aspect, when we try to build something, it becomes quite cumbersome in our on-prem system. So there exactly we are taking help from the cloud. Apart from that, there is another important topic is the responsible AI, where we are talking about the practice areas like accountability, fairness, equity, explainability, safety, security, data privacy, and social environment impact must be integrated throughout the machine learning lifecycle. This responsible AI practice brings a lot of visibility, interpretability, and explainability to our model, so that at various stages of the life cycle, model life cycle, we can question like, is the data correct? Is the data bias free? Are we talking about the right kind of algorithm? Is my data the right representations of all the classes what are being used in our training set? Is the model explainable enough so that anyone who is not technical can understand it? Because most of the time model are kind of a black box model. So which feature is important? Which features are impacting the model prediction with the model prediction? And we can explain, if we can explain top three features which are increasing the risk of, let's say, a credit model, then it will be acceptable by the business people, because they know exactly which features or predictors are need to be monitored or kind of tracked throughout the model lifecycle. With all this feature, if we talk about Amazon SageMaker is kind of a purpose-built machine learning platform, which is offering a wide varieties of capabilities across all the pipeline and modules. In the data preparation phase, Amazon SageMaker is having the ground truth, then data wrangler, then the ETL tool Glue. They are helping us to pre-process, clean, load, and ingest data quickly to the model pipeline. In model building stage, we can use the SageMaker notebook instance, and an excellent tool is SageMaker Notebook Studio. I'm going to use SageMaker Notebook Studio to build the pipeline in the demo section. Now, when we're talking about the SageMaker to build the model, SageMaker is offering various kind of techniques. One is that we can directly go to SageMaker and we can use the already pre-built container, and most of the model machine learning frameworks are already available there, like scikit-learn, TensorFlow, different deep learning model, and NLP models all are available in SageMaker pre-built containers. These containers are already registered in ECR, Amazon Elastic Container Registry, and we just need to get the image and we can use it in our model. We can also build the model in-house and locally, and then we can bring our own container to SageMaker. That options is there. Third one is that we can build the script, and we can just deploy the script in SageMaker to use their own framework, and we can train the model. And with this, there is a excellent training and tuning facilities is also there. We can use various combinations of hyper tuning parameters, and we can train multiple models together by using the hyperparameter jobs, and within 15-20 minutes we can have different result, and then we can find out which is the best fit model for our use case. That way we can save a lot of time. Otherwise, a lot of time the model takes hours, and if we need to go through this experimental phase, we need to run the model one by one. That doesn't fit in a lot of cases. So this particular capability helps us to experiment with various models, and models are registered in a model registry, which is easy to track and easy to maintain, and that I'm going to show you in the pipeline phase as well. The last but not the least is the model serving capability, which is the deployment. And in SageMaker, we have a batch deployment endpoint and the real-time endpoint. And the real-time endpoint can be invoked by any Lambda function. It can be then exposed to AWS API gateway, and then any consumer applications can use the prediction result real-time by sending the test data. In the batch transform prediction, We generally use it for batch data, test data, and then we get the prediction in a batch format. This is a high-level architecture which is going to be deployed in the pipeline stage. Here, there are two different pipelines. On the left-hand side, you can see the model building pipeline, and the second one is the model deployment pipeline. The template I'm going to use here, the model build, train, and deploy. Let's go to the demo phase. It will be easy to understand there. This is again the next level of detail here. This entire pipeline can be secured with the VPC, and or we can then apply our IAM access management policy, key management policy to make the entire pipeline secure, which is the general practice in production. And after that, we are also using the S3 bucket, which is our primary storage of all the model artifacts, code artifacts, test and train data, and all the temporary files. And endpoint is also kind of secured, and we can also apply the auto scaling mechanism on the endpoint by using the endpoint configuration. And that can be done through the AWS console as well. AWS CloudWatch is used to monitor the entire pipeline. Cloud event and event bridge is used to trigger all the event. Cloud formation stack is used to create the cloud formation and create the template. If we want to use it later in any other environment, we can directly use that template. Okay. Now we just talked about it. Let me go to the demo. I'll now switch to my AWS account. Just give me a second. Okay. I hope my AWS
yes,
account
we
is
see the
visible.
console now, Sarbani.
Yeah. So before starting the demo, if anybody has any questions or query, I would love to address. Okay. Let's move on to the console here. Here I have, I'll be using the SageMaker. So the SageMaker, I just already opened one here. In the SageMaker console, we'll go to the SageMaker domain and studio. In the SageMaker domain, this particular domain, I have several users created. Right now, I'm using the SageMaker admin. It's just a name. It has nothing to do with the admin versus non-admin access. It's just a name here. Here, I'm going to launch the app under Studio. Once I'll click on it, the Studio will start open. I have already opened one Studio because it takes some time. So one Studio will open. It will look like this. This is the normal Studio. In SageMaker Studio, there are several ways we can launch the solution. Jumpstart is an excellent solution where we have a lot of pre-built solution what we can launch here. But right now we are working on pipeline. So for that, we'll first create a project. I'm clicking on here, SageMaker resources, this particular icon. In SageMaker resources, I'm selecting, there are a lot of SageMaker resources are available here. Project, Data Wrangler is used to pre-process and clean data. This is a data processing tool. Feature store is used to store the feature. It's kind of a feature engineering, feature extraction. This is an excellent when we deal with a lot of features, and it can be reused by anyone who is using in other projects. Feature store can be used online as well by the inference pipeline. Then the next one is the pipeline, what we'll be using. Experiment and trials, I'm not using it here, but this is the tool which is used by the data scientist when we develop the model, and we generally iterate through several loops and several phases and experiment with different models, different algorithms, different kind of data set and hyperparameter, and we try to get the best fit model. Model registry will be using in our pipeline. Endpoint will be used. Okay, compilation job is not used. Okay, I think then let me just select project. In the project phase, I'm going to close everything here. Now project, I can create a new project. In the create new project, there are they have already given some templates. So I can use that, choose project template here. And the templates are in the down. There are a couple of templates, lot of templates actually given here. If we just monitor, this is a building, training, deployment, and monitoring. And there are various templates. I'm going to use this one, which is kind of good to start. Here we are going to cover all the three different pipelines, like building, model training, and model deployment. And data will be processed inside the pipeline. I'll show that. So once this is selected, I'll click on select project template. And then it's asking for a project name. I'm just giving demo 1. It's a project name and kind of description. Can be okay. We can create our own tag. Otherwise, AWS will create its optional tag with the project name and some random numbers. And let's say create project. Now this part will take some time. So I have already created a project with this name. Let it be there. I'll just close it, and I'm already opening this one. So this project I created 7 hours ago, as it is shown here. This particular project, once it is created, it will show different tabs here. Now repositories are kind of our Git repositories from which we are going to launch the solution. We can also create our own repository, but right now I have used a local repository here, which is going to use a Abalone data set, which is a kind of very known data set in AWS solutions and projects, where we are going to predict the age of species by looking at various physical properties and attributes. This is a supervised learning problem, and output is the age. So it's a regression technique we are going to apply. In this particular problem, we are going to apply a model XGBoost, which is a pre-built model available in AWS Sagemaker and registered under ECR. We are going to use that image. Okay, we are not going to go deep inside all the data pre-processing stage because that depends on your data as well. So once important is that there are 2 repository has been created. One is the model deployment and model building. Where are they? If I click on this, the first one, this is the directory. Here we can use, this is the my project. There are 2 different subfolders are created, model build and model deploy. Let's check the model build. Under the model build, this is the main pipeline project, Sagemaker pipeline projects. Now this is one option is given where I can run the pipeline in the SageMaker notebook instance itself. Like here, if I can start executing all the notebook stages, it will trigger the pipeline. But I'm not going to doing this. I'll be using that other console. But this option is here. Now the next codes are here. So in the pipeline Abalone folder, there are 3 different codes are here. Preprocess.py, pipeline, and evaluate. As the name suggests, the pre-process is kind of used to pre-process the data. Here we'll see all the data paths, S3 bucket, feature names, and then some pre-processing formula and functions are used here. Then pipeline PY is actually defining all the pipelines. So here you can see first we have to define all the pipelines, and these are the different pipeline libraries are loaded here. After that, if we just go down, here we are talking about all the get pipeline method, where we are talking about the pipeline projects, what is the pipeline name, and then other parameters. Now, how to use this particular project for our own data set and own parameters. Now, everything can be customized from the previous screen. Now, if I go back to my pipeline screen, here, let me just close the coding part. Here, you can see these are the 2 repositories that we are talking about. Now, let's look at the pipeline. So here you can see the moment we'll launch the project with that particular template, it will automatically create the base version of the pipeline. So this is the base version. Now, if I double click, it will show me all the details. Here you can see I have already executed this pipelines multiple times. This pipeline is kind of showing me all the graphs together. You can see, let me just, okay. Okay, so these are the different pipeline stages: pre-process, then train, then evaluate, check, evaluation, that check MSC, the evaluation metrics, and then register the model. Now here, this entire pipeline is built with this graphical interface. We'll see that once we'll execute it. And here is the parameter. Now, when we call the pipeline, we can also change this parameter. Right now, the pipeline is called with processing instance type ML-M5X large. Then there is one instance I have used. Then training instance, the same. Now, model approval status, you can see here, it's set as pending manual approval. Now, how is it working here? There are two, the pipeline has two different phase, as you see, model building and model deployment. Now, how does it work? The entire code base is here. So whenever there is any change in any code, that will be pushed to Git, and if I commit the code, immediately the Git commit will trigger the code building pipeline. Once the code building pipeline will be triggered, it will automatically start executing the pipeline here, and finally it will register the model in the model registry. Let's look at it. Now I hope our screen is, let me just close it. Okay, so this project we are trying to create. Oh, it's still creating. Okay, no problem. I'm opening my other pipeline. Here, if you look at the pipeline, let me just execute a new pipeline here. So here, start an execution. I'm going to start an execution. Either I can change the code which will trigger the pipeline, or easily even I can trigger another execution from here. If I start execution, it's asking for name, demo 1, demo execution 1, and here you can see all the parameters. Now I can change the parameter as well. I can change it, make it as large or something. I'm not doing that. And this pending manual approval means once this pipeline will create the model will not be deployed on the endpoint automatically. It will wait for the approval. And here exactly it needs a manual intervention, and that is done willingly because we want to review the model. We want to review the result of the model, and then the data scientist or whoever is the approver of this entire model pipeline, he or she will approve the model. Then it will go and it will build the endpoint. Let me just start this model pipeline execution here. So you can see successfully created an execution. We can also view the details here. Okay, now you can see visually the first level of process is triggered here, which is the pre-process step. Now we can also see all these processes here in the SageMaker itself. This is the SageMaker console. Okay, so in the SageMaker console, if we go here, sorry, let me open another window. So this particular pipeline triggered the processes. Let's see what are the processes running here. In the SageMaker console, we can see several tabs. One is that notebook. Right now, we are not doing anything here. We are mostly interested here in the processing job units. Okay, so you can see a minute ago, I have just triggered these processes. So now you see one pipeline just triggered so many processes here. These are all completed, the old one, I guess. And this is one now it's in progress. So there you can see the name as well, profile report. It's now here, it is pre-process. abundant data. So actual data pre-processing just started here a minute ago, and it's now running for a minute, and then it has also run several other data modeling, evaluate. These are the previous one what I ran. These are all completed. They just took hardly 4 minutes to complete because the data set is smaller as well. Now let them run these processes. Let's see if there is anything running under training. Hopefully not, because training is not yet started. Okay, it started as well. You can see the training job is also started here. If we click on it, we can see the model training job, which is defined in our pipeline building code. This is triggered the training here. Now let's look at where it is running. By in terms of coding, if we go back here, okay, I've closed it. So here, this is the model path here. So the estimator, XGBoost estimator, SageMaker estimator is XGBoost, what we are using here. Here the image URL, this is the URL of the container image where we already have the pre-built XGBoost environment, which is available within SageMaker. And then these are the instance count and which training job it will trigger. Then here we are also triggering some hyperparameter as tuning job, and finally once it will complete, then the training model will be available in the model register. So here we are going to register our model in a model registry. Where is it? If I go here, this was my model. Let me just again close everything, otherwise it doesn't refresh automatically always. Let me just open this. I always start from the project so that I can track everything. So here, then I'll go to the pipeline. I'll check the pipeline. You can see the status is executing. Then I will check, okay, pipeline is fine. It's nothing built here. Now, if I go back to my project, there is another experiment. We are not doing anything here. We are also using the model registry. In the model registry, we'll see a model group has been created. So here you can see, this is the very interesting and important artifact, the model artifact. We can see 1, 2, 3, 4 different versions are created. One is definitely the first version when I installed this pipeline for the first time. After that, I created one version. This is the version 2. And this is I already approved. I approved it, and then it created the model endpoint. And now the staging version is showing as production, and it is now showing who has last modified the user group of the SageMaker Studio. Now, after that, 3 and 4, these two versions were not approved. I did not approve because I wanted to show here how to approve that. So these are currently under pending state. So these are the model created by the pipeline, registered in model registry, sitting with the status pending. We can also see them on the SageMaker code build console. Now, whatever is created in the SageMaker Studio, everything will be visible on the SageMaker console or code pipeline console or S3 console, everything the way AWS consoles are available. So here in the code pipeline, right now, I have not triggered anything through code. I just created the pipeline execution manually on the screen. So I'll just come here on the pipeline. Let me see what is the latest pipeline.
The Sarbani,
Okay. Sure.
Just a quick time check. We
Sure.
have another 5 minutes.
Okay, great.
Yeah.
Okay. So here I can show you. So this pipeline, you can see it's already in progress. But this one is this one, the previous one, which is in pending state. Here you can see all the stages like build, then deploy staging. This is succeeded, testing staging, now approved deployment. Now you can see that is one pending. So approval is pending here. I can approve the model from here, or I can approve the model from the pipeline console as well. If I go and just approving, sorry. Just approved it, or we can also reject. Now, once I approved, the action is approved. Now let's see, the model will be approved after a certain point of time. It may take some time, but this is the approval model. Now once the approved model is approved, how does it look like? The status will be approval, and then we'll see it here, and the same model will be deployed on the endpoint. Now how to go and check the endpoint? We can see the endpoint at various stage. If I go back to my project stage, there, whatever model will be approved, that will create the endpoint. You can see there is only one endpoint already created. This is in service. Now if we double click, we can also test the data through this endpoint here. We can create lot of monitoring script and schedule how to monitor the data quality, the model quality, by putting the model evaluation metrics, explainability. There is a AWS Clarify SHAP. Algorithms are used to explain the model features and prediction. Model bias metrics report we can create. So all the artifacts are now, all the actions can be taken on the model endpoint. Now this model endpoint is also available here under the SageMaker. The same thing, we can also use it here as well. So whatever way, so there are two model endpoint created. You can see, if I click on it, it will take me to the edit configuration page. And here in the runtime mode, we can configure the endpoint setting by using a lot of other parameters. So here we can see very important feature is that configure the auto scaling, where we can automatically scale the endpoint when, let's say I am getting 1,000 test data for which I have to predict real time, or instead of 1,000 I can get 10,000, depending on the latency requirement or SLA. We may need to auto scale the endpoint. So that is exactly going to the production. This is the pipeline endpoint. So this is very important endpoint, and whoever wants to try the causes, whenever we deploy everything, or we do any kind of demo, we have to clean first. We need to end, or we need to delete the endpoint, because that takes a lot of cost. So if it is test, after the demo, I'll go and I'll immediately remove my endpoint, because that's quite a lot. So I just click all of them, and I can just go and delete. Also, we need to make sure for testing purpose, nothing is running left. So if right now a lot of things are running on my processing page, and I'll wait for them to run, and after that I'll check nothing is running, because whenever something is running, they all are incurring cost. Processing jobs, training jobs, sometimes training jobs run on a very high end machine, then it is quite costly affair. So that's kind of end of the pipeline building. There are a lot of things you can do, but important is this, model registry and the endpoint, which help us to track all the model versioning as well as the endpoint for the production. So with this, I can end here, and then I'm open for any questions.
I have to say, Sarbani, myself, I've been working on AWS for close to 10 years, but ML space is something where I've not ventured much. And I believe this has been the best way to engage and understand deep dive, like a crash course, if not, right, for me. So thanks a lot. It was very insightful for me. Team and community, the floor is open for questions to Sarbani and to Wendy. Wendy still has stayed along with us. So if there are any questions for our speakers, please open up.
Hey guys, I have a quick question if no one else does yet.
Sure, Fahan.
I'm just trying to start, wrap my head around ML ops, and this seems like a great jump off point. But have you guys, either of the speakers today, have any experience with using something like Databricks to kind of do something similar? It also seems to do things like data prep, and also has a feature store, and et cetera, et cetera. So is there a comparison that you've ever done? Because I think Databricks will support all three clouds, right?
Yep, true. I don't have working experience in Databricks, but yeah, I have been, trying to do some demo, and because I found Databricks is really good in terms of data, as you said. For data pipeline, data framework, data ingestions, Databricks are kind of having a lot of good features. And as you say, Databricks, they have the workspace in AWS, Azure. Azure and Databricks they are quite compatible, and they also do have the AWS workspace, and I think with GCP as well. And Databricks is similar to the SageMaker. They have end-to-end machine learning pipeline, starting from the data acquisition, data ingestions, and then building pipeline and endpoint everything. Because then I think Databricks can be it can be integrated with the Delta Lake as well, which is another good place to process with the data. Yes, Wendy.
Yeah, that's a good question. Yeah, I haven't used it myself, but it's starting to grow in the market in Australia.
Yeah,
But
it's
it
really
has
good.
great integrations with Azure and AWS.
Yes, with Azure, yeah. But yes, right now I can see in the MLOps, probably we need to think about some cloud agnostic way to build the stuff, because some customers are coming up with AWS preference, somebody is coming up with Azure preference, and sometimes it's technical and political. Like some managements are kind of quite focused on Azure, then depending on some partnership, sometimes from the technical side, it's sometimes really challenging to pick up one module from AWS, one module from Azure. Some are open in-house like Kubeflow, MLflow. They are also kind of good open source to be used within the pipeline. And I know people are building a lot of complicated infrastructure where something is coming from MLflow, going to SageMaker, coming to the endpoint. Yeah, but yeah, this area is a lot of things are happening in this area.
So there's one more, I guess, just a very specific question to my current project is, we have a data science workflow that I was evaluating. It's written predominantly in R. And I would say 90% of what they're doing is data cleaning, data augmentation, data prep, which I can imagine can be done in an ETL flow, something like Spark.
Yes.
However, there is one portion, and that is k-means clustering. So I find myself, I'm kind of hesitant, but I find myself just wanting to say, okay, I'm going to use Glue or EMR to do all this, the Sparky work, for lack of a better term, and then just pushing that data into, say, a Python VM instance and doing k-means on the entire data set. So I guess my question is that either Databricks or SageMaker or any experience that you guys have, how would you solve specifically, say, something like k-means? Is that something we can do in an ETL pipeline, or do I always have to go Python VM?
I had a colleague who used Spark RL. So it's a package within R, so you can try that as well.
Oh, okay. What is it called? Spark?
Yeah. I need to set it with Spark LR. Yeah.
Okay.
It's like a version of Spark in R. Yeah.
Do you think that would let me do, like, implement an ML library like k-means or ML
Yes.
across the? Oh, nice.
Yeah, it's the equivalent. So we used it academically as well. You can transfer, you can interchange with into Python as well at the same time if you need to revert back to Python in your notebook.
Oh, wow. Okay. And do you think I could run that on EMR or Glue, or do you think I'd have to have my own kind of Spark cluster?
I think you can, because now there's a notebook in R that was just released about approximately November. So you can interchange and use either the choice of R or Python. Yep, within SageMaker.
Wow. Okay, that's awesome. Thanks. That just solves my problem. Appreciate it, Wendy.
You're welcome. Yeah, that's a great demo, Sarbani. Yeah, thanks for taking us through the new, Amazon Studio as well. That was just released.
Yep.
Right. Brilliant. That's great. Do we have any more questions for our speakers team? All right. If not, I think I would like to thank both of you on behalf of everyone, Sarbani and Wendy, for actually giving your time and actually sharing your knowledge on this platform. It was a It was a knowledge-packed session. I think everyone would agree on that. Thank you for this. And for all the attendees who are here, we all can take good feedback. I think it will be highly appreciated. I've shared the link in the chat. It's feedback, good, and what can be improved for us as user group, as a community, and as a committee as well. And for the speakers as well, what can be done better. And Wendy, as a community builder, she's going to be doing many more. Sarbani, in her position, she's been doing a lot of talks. I think that will be helpful. And of course, feel free to follow us on the links that I've shared. I don't want to sound like a podcast or a guy who's saying follow us, hit like. But yes, it helps to have the reach. Follow us on these where as per your convenience. We are across Facebook, YouTube, Meetup, and yeah, it would be good to have this community grow and have them growing. And I have my colleague Salam back on the call, and on behalf of everyone here, thank you again. Yeah,
Thanks for having us.
highly appreciate that.
Thanks, everyone.
Thank you. Nice to meet you all, and good evening.
Bye-bye.
Have a good evening, everyone.